May 3, 1943. Konyu Cutting, Thailand, 2:47 a.m. A British sergeant named Thomas Mills gripped a 10-pound hammer in blistered hands. For 16 hours straight, he'd been drilling holes into solid rock for the Japanese engineers. But here's what his guards didn't notice. Every third hammer strike deliberately missed the drill bit by half an inch. This wasn't exhaustion. This was warfare. While guards screamed "Speedo! Speedo!" and bamboo canes cracked across backs, over 12,000 Allied prisoners were waging a silent war against their captors. They weren't just building a railway through hell. They were sabotaging it from the inside, using nothing but wits, courage, and the very tools forced into their hands. This is the untold engineering story of the Death Railway, where every sleeper laid, every bridge built, and every tunnel carved became a battleground of resistance. The year was 1942, and Japan had a massive problem. After seizing Burma and the British, Japanese forces needed a supply route to feed their armies. The sea lanes around the Malay Peninsula had become death traps. American submarines were sinking Japanese ships faster than they could be replaced. Following devastating defeats at the battles of Coral Sea and Midway in May and June 1942, Japan's naval dominance crumbled. The solution? An overland railway connecting Bangkok, Thailand to Moulmein, Burma. There was just one catch. British engineers had surveyed this route decades earlier and declared it impossible. The proposed line would cross 260 miles of the most hostile terrain on Earth, mountains soaring 6,000 feet high, rivers prone to flash flooding, and jungles so dense that visibility dropped to mere feet. Monsoon rains could dump 40 inches in a single month, turning structure sites into swamps. But Japan didn't care about impossibility. They had something the British didn't – expendable slave labor. By April 1943, the Japanese had assembled a workforce that would make pharaohs envious. 60,000 Allied prisoners of war – British, Australian, Dutch, and American – plus an estimated 190,000 Southeast Asian civilians known as Ramusha, conscripted from Burma, Malaysia, Thailand, and Java. The orders were simple and brutal – complete 260 miles of railway in 12 months. The Victorian British estimated it would take 5 years with modern equipment. Japan gave their slaves 1 year with hand tools.
Let's be crystal clear about what building a railway actually meant in the Thai jungle in 1943. This wasn't laying track across flat prairie. Every single mile presented engineering nightmares that would challenge modern construction crews with bulldozers and excavators. The prisoners worked with tools that belonged in a museum: pickaxes, shovels, 8 to 10-pound hammers, and bamboo baskets. That's it. No jackhammers, no dynamite conveyor systems, no power tools. When rock needed to be blasted, prisoners had to drill holes manually. One man held a metal drill bit while another struck it with a hammer, over and over, hour after hour. Captain Ernest Worden of the Argyll and Sutherland Highlanders described the process. One man holding a drill bit, another hammering it. Then you'd fill the hole with explosives, blast the rock, and carry away the debris in baskets on your shoulders. The engineering specifications were brutal. The railway required over 600 bridges spanning rivers and canyons. Hellfire Pass, officially called Konyu Cutting, needed to carve through solid limestone to a depth of 82 feet and a length of 246 feet, all excavated by hand. Temperature during the day reached 104 degrees Fahrenheit. Humidity stayed above 80%. Mosquitoes carried malaria. Contaminated water spread cholera and dysentery. Tropical ulcers from tiny cuts turned into infections that ate flesh to the bone. But here's what made the situation truly impossible. The prisoners were starving. Daily rations consisted of 680 grams of rice, 520 grams of vegetables, and 110 grams of meat or fish, on paper. In reality, prisoners received far less. Guards skimmed supplies. Transport delays meant food arrived rotten. By the time Private Reginald Twigg reached his work camp, he weighed 98 pounds, down from 160. And then came Speedo. In February 1943, Japanese engineers realized they'd fallen behind schedule. The solution? Push harder. Guards began screaming, "Speedo, Speedo," and forcing 18-hour work shifts. No rest days, no sick leave. If you couldn't stand, you were beaten. If you couldn't work, you died. Between July and October 1943, the death rate exploded. One man died for every railway sleeper laid. But the Japanese engineers made one critical miscalculation. They assumed starving, beaten prisoners would simply follow orders and build their railway exactly as designed. What the guards didn't realize was that these weren't just laborers, they were soldiers, engineers, technical specialists, men who understood exactly how a railway worked and how to make it fail.
Resistance on the Death Railway took a form the Japanese never anticipated: engineering sabotage. Let's start with the most ingenious method, the termite strategy. Private John Swan, a British sapper, discovered something fascinating about Thai termites. They devoured soft wood, but avoided certain hardwoods. When guards ordered prisoners to select timber for railway sleepers, the prisoners deliberately chose wood with subtle rot or termite damage. They'd inspect logs, find the ones with internal weakness, and mark them for selection. Here's the brilliance. Termites work invisibly inside wood. A railway sleeper might look perfect on the outside while being hollowed from within. The Japanese inspectors would see solid timber and approve it. 6 months later, that sleeper would crumble under the weight of a loaded supply train. Former POW Ernest Gordon later testified, "We never cooperated willingly. We worked at bayonet point and took any risk to sabotage the operation whenever opportunity arose." The drill work sabotage was equally clever. Remember that manual drilling process, one man holding the bit, another hammering? Prisoners developed a technique where they deliberately strike off-center every few blows. This created holes that were slightly crooked or incorrectly angled. When explosives detonated, the rock wouldn't fragment properly. It would crack in the wrong direction, creating unstable faces that would require reblasting. The Japanese blamed incompetent coolie labor. They never suspected trained soldiers were doing it deliberately. Bridge construction offered even richer opportunities. The famous bridge on the River Kwai actually consisted of 2 bridges, a wooden one built first, then a steel and concrete structure. Most bridges along the route were entirely wooden, constructed from logs cut in the surrounding jungle. Prisoners assigned to pile driver teams developed a brilliant technique. Pile drivers were massive wooden hammers, hauled up by teams of men pulling ropes, then released to pound bridge pilings into riverbeds. Prisoners discovered they could deliberately time their rope pulling to create irregular impact patterns. Instead of driving piles straight down, the impacts would be slightly off-angle. The result? Bridge foundations that looked solid but were actually unstable. Add monsoon flooding, and those bridges would wash away far more easily than properly driven pilings. Australian Lieutenant Tom Uren recalled, We worked slowly whenever possible. If you swung the pick quickly but let it drop next to an area you'd just cleared, the earth came away easier, but to the guards it looked like you were working hard. The effort was minimal.
Railway embankment construction provided another sabotage vector. Prisoners had to build embankments by carrying earth and stone in bamboo baskets. The engineering principle is simple. Embankments need proper compaction and drainage to remain stable. Prisoners would deliberately layer the embankment poorly. Soft earth next to hard stone, creating weak zones. They'd skip compaction steps when guards weren't watching closely. When monsoon rains hit, water would seep into these weak zones and entire sections of embankment would collapse. Tool sabotage was constant and creative. Prisoners would deliberately drop tools into rivers during bridge construction, claiming accidents. Shovels would break after being stressed on concealed rocks. Drill bits would be dulled by accidentally striking them at wrong angles against stone. The Japanese brought limited replacement supplies. Every broken tool meant delays while replacements were sourced from Bangkok or requisitioned from dismantled railways in Burma and Java. Medical Officer Major Hunt documented a remarkable incident. A work party was accused of deliberately mixing water into cement for a bridge footing. The Japanese sergeant couldn't prove it. Cement mixed with excess water looks normal until it's supposed to set. The footings remained soft, forcing it to be torn out and rebuilt, consuming 3 days. But perhaps the most dangerous sabotage involved the railway track itself. Railway construction requires precise alignment. Rails must be exactly parallel and properly spiked to sleepers. Prisoners working on track-laying teams would leave spikes slightly loose or deliberately space them irregularly. They'd adjust rail alignment by millimeters, tiny enough that Japanese inspectors wouldn't notice, but significant enough to cause problems. When supply trains ran at speed over these sections, the track would gradually shift, creating the dreaded rail creep that caused derailments. Now here's where this story gets even more remarkable. The prisoners didn't just sabotage randomly, they organized it. Camp commanders established secret communication networks, coordinating sabotage efforts across dozens of work sites, spread over 260 miles of jungle. They had to do this under the noses of guards who would execute them for resistance.
The Australian 27th Infantry Brigade, under Lieutenant Colonel Charles Cappy, maintained military structure throughout captivity. This became the backbone of organized resistance. Work parties were designated as forces: F Force, H Force, D Force. F Force alone consisted of 7,000 men divided into battalions, each commanded by experienced officers. Even in jungle camps with prisoners dying from cholera, these officers maintained command chains. Here's how communication worked. Prisoners assigned to cook duties moved between camps delivering food. These men became couriers, passing information verbally, since written messages were too dangerous. A cook would memorize something like, "Bridge team at Kinseok needs to know foundation depth specs." Seemingly innocent construction talk, but actually coordination for sabotage timing. Medical officers played a crucial role. Doctors like Robert Stevens moved between camps treating sick prisoners. Japanese guards allowed this because cholera epidemics threatened their own troops. These medical officers passed information between senior commanders, coordinating which bridges to target, which embankments to weaken, and when to escalate tool sabotage. The chaplains were particularly valuable. Reverend Ross Dean and other chaplains held religious services that guards permitted. These gatherings became information exchanges. A prayer session might include coded language. "May our work today be as solid as the foundations we built yesterday," a signal that yesterday's foundation pour had been successfully sabotaged. The concert parties provided cover for planning sessions.
Yes, incredibly, prisoners organized entertainment, singing groups, comedy acts, even makeshift orchestras. Guards encouraged this, believing it kept prisoners docile. What guards didn't realize was that rehearsals provided cover for officer meetings where sabotage tactics were discussed and refined. Battalion commanders held secret conferences at night, huddled under mosquito nets, speaking in whispers. They debated risk versus reward. Was it worth sabotaging a particular bridge if the guards were running brutal inspections that week? Should they escalate embankment sabotage now that the monsoon season was approaching? Ernest Gordon's memoir revealed that senior officers operated under a strict code. Never sabotage work in ways that would endanger fellow prisoners. For example, they wouldn't weaken bridges that prisoners used to cross rivers. They wouldn't sabotage food storage facilities. The target was always Japanese military supply capability. The organization faced a constant ethical dilemma. Better work quality meant better treatment from guards, more rations, and fewer beatings. Sabotage meant risking collective punishment. Guards would beat entire work parties if construction failed inspections. Officers had to calculate, was delaying the railway by 1 week worth 10 men dying from punishment beatings? Different commanders made different choices. Some British officers in certain camps reportedly cooperated with Japanese engineers, believing better work meant better survival odds. This created tension with Australian units, who maintained more aggressive sabotage policies. The movie The Bridge on the River Kauai later portrayed this cooperation, which outraged survivors. Ernest Gordon stated clearly, "We never did so willingly. I must make that clear for those men living and dead." The sabotage was working. Japanese engineers were reporting mysterious structural failures, tool shortages, and construction delays they couldn't explain. But in July 1943, everything changed.
The Speedo period, July to October 1943, turned the Death Railway into a true charnel house. Railway construction had fallen months behind schedule. Japanese High Command in Tokyo ordered completion by October. No excuses, no delays. The order came from the top: finish the railway or face court-martial. Local commanders responded with insane brutality. 18-hour work shifts became standard. One prisoner, John Leslie Graham, reported, "We worked from dawn until after midnight. Guards screamed, 'Speedo! Speedo!' and beat anyone who slowed. If you couldn't hold a tool, they'd make you hold a heavy rock above your head until you collapsed." Sabotage became suicidally dangerous. Guards began conducting brutal inspections, checking every section of track, every bridge temper, every embankment. Prisoners caught with loose spikes or improperly laid sleepers faced immediate beatings. Several men were beaten to death during these inspections. At Hellfire Pass, 69 men were murdered by guards in 12 weeks, beaten to death with bamboo canes and rifle butts for working too slowly. Medical officer Rowley Richards described watching men lose the will to live. "I'd see fellows recover from dysentery or malaria, start getting better, then just give up. They'd look around, see men dying, and think, it's too hard. Then they'd die within days, even though physically they were recovering." The death statistics tell the story. Of F-Force's 7,000 men, approximately 3,000 died within 8 months. That's a 43% mortality rate. 1,000 Australians dead, 2,000 British dead. The survivors emerged with permanent injuries, lost limbs, tropical ulcers that never healed, psychological trauma that haunted them for life. The Ramusha civilian laborers suffered even worse. British Dr. Robert Hardy witnessed Ramusha camps and described conditions that shocked even POW medical officers. He described corpses rotting unburied in jungle, no sanitation, no medical attention, frightful stench. The Japanese treated these civilians as utterly expendable.
Estimated Ramusha deaths range from 80,000 to 100,000. The exact number will never be known. Japan kept no records of civilian laborers. Entire villages in Burma and Malaysia lost their male populations. Cholera swept through camps in waves. The disease killed with terrifying speed. Victims would be healthy in the morning, dead by nightfall. Prisoners had only received one cholera inoculation before leaving Singapore. The rushed schedule meant incomplete immunization. When the epidemic hit, prisoners died in clusters. Some camps reported 20 deaths per day. But the sabotage continued. Even during Speedo, even facing death, prisoners kept finding ways to resist. They couldn't stop. Stopping meant accepting their role as slaves building Japan's war machine. Resistance was survival. Captain Gordon recorded, "A gunner we called Dusty Miller spent his final hours helping other men, carrying their gear when they couldn't walk. He died from exhaustion and dysentery, but he died resisting." The railway was completed on October 17, 1943, ahead of the revised schedule. Japanese engineers celebrated. Trains began running supplies from Bangkok to Mulmeen, feeding Japanese armies in Burma. But the celebration wouldn't last long.
Within months, the sabotage began paying devastating dividends. Allied bombing campaigns targeted the railway relentlessly. RAF and USAAF bombers struck bridges, tracks, and stations. The most famous target was the bridge on the River Kwai, nearly impossible. Track sections with loose spikes and irregular spacing. After bombing, engineers couldn't tell which sections were bomb-damaged and which were sabotaged, so they had to rebuild everything. Japanese engineers filed reports complaining about mysterious structural failures, even in sections not hit by bombs. Bridges would partially collapse under heavy loads. Embankments would slide during monsoon rains. Track sections would require constant realignment. The railway required massive ongoing maintenance, consuming Japanese resources and manpower desperately needed elsewhere. Prisoners captured after the war's end were still being forced to repair sections that kept failing. Allied intelligence intercepted Japanese communications expressing frustration at the railway's unreliability. Supply trains ran irregular schedules because engineers couldn't trust the track. Several supply trains derailed, killing crew and destroying cargo. The most significant impact, the railway never achieved its strategic purpose. By the time it was completed in October 1943, Allied air superiority in Burma had grown strong enough to bomb supply convoys at will. The railway became a target rather than an asset. Japan poured resources into building and maintaining a supply line that couldn't reliably deliver supplies to the front lines. After the war, investigators estimated that less than 30% of supplies loaded in Bangkok actually reached Burma intact. Between bombing, sabotage-induced failures, and operational difficulties, the Death Railway failed as a strategic project. Prisoners had waged guerrilla warfare using nothing but hammers, shovels, and engineering knowledge, and they'd won. The Burma Railway teaches us something profound about resistance and human dignity. These men were starving, diseased, beaten, and worked to death. They had every reason to simply comply and maximize their survival odds. But they chose resistance. They chose to fight with the only weapons available: their knowledge, their skills, and their refusal to surrender. Modern military engineers study the Death Railway sabotage in courses on asymmetric warfare. The techniques prisoners developed, using enemy tools against enemy objectives, organizing resistance under surveillance, maintaining morale under extreme conditions, these principles remain relevant today. The psychological aspect fascinates researchers. How do you maintain resistance when every day brings new horrors? The answer lies in what psychologists call agency, the sense of having some control, some choice, some ability to affect outcomes. Prisoners couldn't choose whether to work, but they could choose how to work. That tiny bit of agency, deciding to hit the drill slightly off-center, selecting the weaker log for the sleeper, loosening that spike just a fraction, kept men sane when insanity seemed logical. Today, the bridge on the River Kwai stands as a tourist attraction in Thailand. Tour groups photograph the curved steel spans, now repaired and operational, carrying passenger trains across the Kwai River. But walk a few miles north to Hellfire Pass. Stand in that cutting, 82 feet deep, carved by hand through solid rock. Read the plaques listing names of men who died there. Then imagine how many of those hammer strikes were deliberate acts of war.
The final toll, over 12,000 Allied POWs dead, between 80 and 100,000 civilian Ramusha dead, all to build a railway that lasted less than 2 years before being largely abandoned after Japan's surrender. At the Kanchanaburi War Cemetery in Thailand, 6,858 graves hold Allied prisoners. The headstones list their ages, 19, 22, 25. Boys, really, who died building a railway they were simultaneously destroying. In post-war trials conducted from 1945 to 1951, Japan prosecuted 111 personnel involved in death railway construction. 32 received death sentences, but no number of executions could bring back the dead or heal the survivors. The last known survivor of F-Force, Jim Atkinson, died in 2011 at age 93. He spent his final decades telling his story to school groups, warning against the horrors of war, and honoring his friends who didn't come home. Before he died, Atkinson said something remarkable. "We won, not the way soldiers usually win. We didn't kill the enemy or take territory, but we resisted. Every day we resisted. And that railway never worked the way they want it. We made sure of it." That's the untold story of the Death Railway. 12,000 men who died building it while simultaneously making sure it would fail. If this story of engineering resistance under impossible odds fascinated you, hit subscribe. We've got more military engineering stories that reveal the problem-solving brilliance behind history's greatest challenges. Check out our video on how Colditz POWs built a glider in a castle attic to escape over Nazi Germany, another incredible example of engineering genius under pressure. Drop a comment and tell us, what other POW engineering stories should we cover? Until next time, remember that true resistance isn't always loud. Sometimes it's a hammer strike that's 1 inch off target, a log selected for its hidden rot, a spike left just slightly loose. Sometimes resistance is built into the very thing they force you to build.